Heyo. Um, Welcome back to Couch Time Math. Except for I am now in a chair. It's got a little rocking to it. I was dressed nicer, you can see but I got cold, so I'm repping one of my many institutions of higher learning that I have attended. um, there's a lot of stuff we still need to do. I'm thinking though we need to start to get to variables soon because the whole point is we're doing algebra. So I want to have one lesson on converting decimals back to fractions, a little extra number stuff, and then we'll get into algebra and like terms. Okay, and we'll just roll through it because if you have the foundation, you're kind of good to go. So decimals back to fractions. And after we get this foundational stuff and we roll through some algebra, maybe we could pick up some geometry along the way. Love geometry. Okay, love it. It's my favorite. It's my absolute favorite. Okay. It's pretty simple because deci is base 10, right? Always go with the Latin roots. There's always going to be Latin or Greek somewhere in math. There's also a lot of French because France was the scene of a lot of mathematics back in the day. And by the day, I mean, like the 1400s, 1500s, those days. You just put over 10, right? Except for in one case. So this shouldn't take long. So I can make up any number, 0.237, right? And to make this a fraction, you just take the 237 part and put that many zeros, right? 3 digits and a 1. There. We're done. These I can already tell are relatively prime. So, no big deal. We can reduce fractions if they're simpler. If you had like 1.6, we'll make that really simple. Make our 6 look a little more like a 6. I can say that's 1 and 6 over 10, right? Because the 0 for the... And now I have myself a really glorious mixed number. Because remember, implicit in a mixed number is addition right here. And I can reduce this. 6 and 10 have a common factor. We talked about factors, right? So that can be 1 and, well, they're both divisible by 2. 6 divided by 2 is 3. 10 divided by 2 is 5. Now, if we want this not a mixed number, mixed being whole and fraction, it's wrong, right? Remember we talked about number sets? This doesn't fit into anything. It's mixed because it's partially whole, partially an integer, and partially a fraction, a rational number. Blech. Let's just make it an improper fraction, which it doesn't mean it's improper. It just means the top is bigger than the bottom. It means it's more than 1. So how do we convert this? Well, the 1 can become, remember, this is implicit addition. 1 plus 3 over 5, which we need to get this into fifths, common denominator. 5 over 5 plus 3 over 5 equals 8 over 5. Pretty straightforward, okay? Ponder that for a second while I find something to wash this off with. See if it's gonna, no, it's not gonna make it. It's not gonna make it. Just like a little journey around my house. I think I'm gonna replace that. I'm over it. I'm over it. All right, hold on 1 second. Did you ponder? Did you ponder the numbers? All right, let's think about a repeating decimal though. Okay, so these are all base 10, deci. Now, let's think about a repeating decimal. Okay, because you go, well, that doesn't work, Becca. Right, it repeats. If I put, what parts do I put zeros forever? No, you don't. And 0.3 is 3 over 10, right? 1 0 and a 1. But 0.3 repeating, we can't just say that 3 over 10 because that's not. So how did we get 0.3 repeating? Do you remember? Maybe you do. This is equal to 1/3, right? Do you remember that? 1 divided by 3 is 0.3 repeating. So here's how you deal with repeating decimals. It's actually pretty incredible, and I don't want to get into why it works because a little bit it blows my mind completely. I guess you could say that you're always one shy of completion. So if you have 0.7 repeating, that is the same as 7 over 9. Go ahead and put it in your calculator. 7 divided by 9 is going to be 0.7 repeating. Now, if you have, let's say, 6/2 repeating, like that, 6/2, 6/2, 6/2, 6/2, 6/2, that's going to be 62 divided by 99. Because remember, just 0.62 is 62 over 100, right? 0.62 without repeating is 62 over 001, right? The amount of zeros as there is a 1. But this you put over 9s. Go ahead and do it. 62 divided by 99 is 0.62, 62, 62, 62, 62, and it never. You're always one shy of completion. So remember, the bar goes over that. Now, there are some complicated versions. You could have like 0.58, and only the 8 is repeated. That gets a little complicated, and you have to do an addition to figure out what the actual fraction is to do that, because you have to do this part and then that part. Over 9s, over 10. So you have to figure that out. It becomes over. Oh, I can't do it off the top of my head, to be perfectly honest right now. I'm just not feeling it. So that's how that goes. All right, this is our last just pure number thing for a while. I love number theory. We could go on and 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 on. But we're not going to right now. Okay? So next lesson is going to be like terms, and then we're going to plow into algebra. Okay? All right. Stay safe. Stay safe.